Welcome back to the Foundation in C# course. We are currently in Module 3, and this lesson we're going to tackle a mini project. Now, a mini project is, just like it was last time, it's a kind of a accumulation of what you've learned so far in this module. And what we're going to do is try and put all the pieces together in a way that allows us to see a little bit bigger picture. One of the dangers of focusing on one little area at a time is that you kind of miss the forest for the trees. You see each tree individually, but you don't see the bigger forest. And so with a mini project, we try to kind of take a step back and look at how these all work together. Because programming isn't about one little thing at a time. It's about a complete application with lots of things coming together and mixing. And the real world, you want and you have to be able to do that work in that environment where there's a lot of things mixed together. So today we're going to cover a mess. And that's what this code is. I've pre-written it for us because I wouldn't ever want you to write code like this. This is just messy. It's awful. And it really does simulate what you'll find in the real world. Now, it may be worse in some ways, but it's actually better in other ways. So let's look at the code and just kind of skim over it. We have our static void main. Remember, that's where we start our application. And our application says int I, so it declares a variable, and then it puts the value of w, which is a method, passing in a value of 0. And then it just writes out a write line of that resulting value. And then it's done. That's it. Well, what does W do? Well, W is right here, and it says, well, create this N and say JE4, which E is this. So where's J? Well, J is somewhere down here. Oh, there it is. And there's J. And it's got a C and an A and an R call and a P call. And, well, there's R down here. And then there's P is up here, and P is calling F, and F is down here, and wow, is that a mess. If you're looking at this and saying, I don't know what's going on, you're not the only one. And that's actually what's going to happen in the real world. You can get dropped into a situation where someone else wrote the code, and it's squirrely. It's just weird, and you just don't understand what's going on. The key is not to panic. Don't get uptight. Don't worry about it. Just say, okay, we're going to take this one step at a time. Now, in this case, we have the benefit of being able to run our code. Hopefully, you can too in your environment. So let's just run this right as it is. And it says 4. That's the value of I. Okay, cool. So why does it say 4? Let's just put another value in there. Let's say 10. 10 is 5. If I put 11 in there, 11 is 5 again. So something weird's going on. We don't think this is the right behavior for our application. Let's start back where it was at 0. The first thing to do is you can just put a breakpoint right here. A simple breakpoint. We hit start. It hits the breakpoint. And we say, okay, let's start looking at our values. Now our values are down here. And there we go. It's a little bit better on the font size. So now we see that I is 0. So that's good. Now we can start stepping through our program. So we use step into, or F11. And it comes down here at W. Cool. We get a value for N and a value for E. E is 0, N is 1. And we go, okay, well, now we got to get a value for all of this. We look through, and now it's calling R, and it's V, and it's R, and it's C, and wow, that's a lot of stuff. And we're now in P, and now I return C, And now we have a value for n. N is now 4. So why is it 4? Well, E was 0, and that's y. And does that make sense? Not really. So now we can start looking at, well, maybe we can put some breakpoints in here that are a little different. So instead of this breakpoint, we can actually disable it. And let's start putting breakpoints in at every step of the process at the end. So we'll put a breakpoint here, and we'll say, instead of conditional, we'll say action. And we're going to say that you want to print out and say input. And this is going to be whatever E is. And the output is going to be whatever N is. And that's for the W method. All right, so we now have the input and output for the W method. Let's do the same thing down here. Put a breakpoint, and we're going to say this is the P method input, and that's V. Output is O. And we'll do the same thing down here. Action. And we'll say this is the F method. The input is X. And the output is Y. And then the J method, right down here. We'll say this is the J method. Input is A. And the output is C. Now, if you're not convinced yet that naming variables is important, I don't know what will convince you. Because nothing here is labeled. So why is A? Why is C? Why we have these things? And you get really frustrated because none of this makes sense. If this said, oh, well, this is the prime value and this is the value of the speed of light, okay, that might make some more sense. You kind of understand, you can kind of look at formulas. But in this case, it's just random letters. All right, so last one here, method R input is V, output is V. Interesting. And just by reading over the code, that kind of stands out to me. If you're passing in a value and passing out a value that's the same, that might not be right. This is why I name my output variables, the variable that I send back, I name it output. That was very clear. Oh, I'm sending back output all the time. And if I'm not, there might be a problem. So now what we can do is we can run this without doing anything else and look at our output window. Now we have the values for the inputs and outputs. What I'm going to do is open up Notepad. I'm going to copy these values into Notepad. All right, so now I have them saved. Now what I can do is I can stop this and come over here and start looking at each of these methods. So let's take the method that's kind of at the bottom. All right, so the method that is at the very bottom, meaning it's actually the top, so it's the method that completed first because it's basically the end of the chain. Because once it completes, then it allows F to complete, which allows P to complete, which allows J to complete, which allows W to complete. So let's look at R. Input is -1, output is -1. Let's scroll down and find R. So let's walk through this in our mind, kind of think through it. Well, V is -1. Okay, now Z is 5, cool. 3 divided by V, 3 divided by -1 is, -3, I believe. That goes into Z, and we return, whoops, that's a problem. So we can see right now, just by running through it, we're returning the wrong value. It appears we should be returning Z. So let's change that. Now let's see how our application runs. The output is still 4, but now let's look at what our methods returned. And I'll come over here and I'll actually paste them down below. And we can look and see that method R is still returning -1. Well, why is that? So we can actually put a breakpoint here and say, you know what? We want to find out more information. So we're going to run it again. This time we put a breakpoint here. -1 coming in. Z is 5. All right. So now it doesn't matter because Z is getting wiped out. So it doesn't matter that it was 5. 3 divided by -1, if we step into that, we now see that Z is -3. Return Z. Well, why is it that we said -1 in our output? Well, that's actually because our breakpoint here, let's stop this. Our breakpoint here was looking at the output and we changed the output. The output should be Z. That's why we had the same value. So now we can undo this. We know that it's actually returning a correct value. We can run this again, and now we see that -3 is our output. Now it doesn't change the value here, but we're starting to move down the trail. And this is where a lot of younger developers who are less experienced get tripped up. They go, oh man, I fixed the problem. And then it doesn't really solve the overall problem. They say, well, that wasn't really the problem. Or they get super discouraged because, man, I didn't solve everything. No, you didn't solve everything. But what you did do is you identified a problem and you fixed it. Now you move on to the next one. Okay? Problems usually aren't just single things. There's a cascade effect that happens where you might find 3 or 4 or 5 issues that aren't really the main issue, but that are an issue. And you need to fix those too. So don't get discouraged if you solve a problem, but not the full problem. Don't get tripped up with the idea that that your solution didn't solve the problem, even though you made a change, because in this case, we did solve a problem. It's just not the overall issue we're seeing. Okay? Now, the other thing that these breakpoints are allowing us to do is understand the flow of the application. I've gone through R, and I know that R is, actually, let's copy this latest value here. Let's copy this and put it in our notepad and kind of wipe out the old ones. So it's made a change. So we know that R is the last method in the chain, and before that is F. So let's go to F, and F is an input of -3, which is what comes from R, and it's an output of, well, I'm sorry, it does not come from R, but F is a input of -3, and it's an output of 0. So -3, y equals 0, -3 divided by 5 into y. Well, -3 divided by 5 isn't a whole number. but we're dealing with int. So there's a problem. Because we're dealing with int, we have the issue of not rounding properly. Should we do something with that? Well, probably yes, but we're not going to do it yet. So right there, I know that I have one problem I need to address by changing over to a double in order to get a decimal number. Because I'm rounding here, that's the problem. In fact, we can determine that for sure by putting a breakpoint there and starting our code over. So -3 is the input. -3 divided by 5. If you notice, if you mouse over this, it actually gives you the value here, x divided by 5 is going to be 0. So it's kind of cool. But that's not really helpful because it's rounding it. So that's why it's returning 0 as its output. But before we go any further, I want to kind of report to you what someone told us. And they told us that they put a value of 1 in and things just blew up. Let's see that. So let's put 1 in place and we're going to hit run. And yep, we get an exception. Now, in this case, it took us right to it. But what if instead we had wrapped that whole thing in a try catch? It made our lives a little harder by putting it with a try catch, and they didn't even catch the exception and just said something went wrong. All right. And of course, I is now a problem. So we have to actually move this up into the catch. And so now if we run this, it just says something went wrong. That's a problem. Well, we can solve that by actually catching the exception. Give it a variable. And then if we don't want to use the exception, not a problem. We can just put a breakpoint right there. Now watch what that'll do. We hit that breakpoint. Now I can go and look at this exception value and see what it says. So it says, okay, here's my stack trace. All right, we can look at that whole stack trace and notice it's quite large because it went really deep. In fact, the exception is in R at line 69. Remember that. That'll get us right to the exception. But if we want to trace this back or start from the beginning, we see that in main, we called, at line 15, we called this next method, which is W. And at line 29, it called the next method, J, at line 58. And J called R. And at line 69, the exception happened. So line 69, we hit stop. We dive down in here and see at line 69, there's our problem. And a value comes in that causes a problem. If we now put a breakpoint here, hit start, we can examine the values and say, okay, V is 0. We can actually look at it here. V is 0, Z is 5. 3 divided by 0, oh, that'll cause an exception. Now we can solve this problem in a number of different ways. If this is on the user interface thread, we could tell the user right here. But since this is so deep in, we might have special rules that we want to apply. One thing we could do is just do a check. Not even do a try catch, just do a check. And say, if V equals 0, then do something. Whatever that something is. Now, what that something might be is to say Z equals 0. And then have down here an else and put this code inside the else. So now only do division if it's not 0. If we run this now, it outputs 4. No problems, because we said that dividing by 0, we just want to say the output or result is going to be 0. We didn't have to throw an exception. We didn't have to even tell the user. But we could tell the user if we wanted to. And if we have access to the user interface, we could say something like this, where we say console write line, assuming a result of 0 to avoid divide by 0. And if we run this, it now tells the user that we assumed a result of 0, and the output is 4. However, if this does not have access to the console, because it's not in the user interface project, that's where we might throw an exception. And you might choose an exception like an argument exception. All right, and there's other exceptions in here as well, but I think that an argument exception is probably our best bet. And say one of our options is just a passive message. The value passed, we cannot divide by 0. All right, that's a user-friendly message that a user can understand. Now, notice there's 5 different options here. We're on number 2. Number 3 is to pass an exception in. Number 4 is to pass in a parameter name. This is kind of cool. This is a little more of an advanced exception thing you could do. For argument exception, you can pass in your parameter as a string. All right, so you can say that's the name of our parameter that caused the problem. So we're going to throw this exception. And if we do, right here we pause because of our breakpoint. We can mouse over this and we can see that it says, let's zoom in with the other zoom in. We cannot divide by 0. Parameter name was v. So it tells us which parameter had the problem. Some code can actually use this to give us more information about that parameter automatically. But at least knowing which parameter had the problem, in case you have 3, 4, 5 different pieces coming in, that can be really helpful. All right, so that's another way to kind of dial in our application and give us valuable information. Now, in this case, it still says something went wrong. But because I know that if there's I can say catch, I can say, well, argument exceptions, I actually want to catch differently. Because now I can say console write line ex.message, because that message allows me to print out the user-friendly message. Now, not all exceptions have user-friendly messages. Some come from other places. That's where this kind of cleanup exception catcher will just say something went wrong. That's not great, but it does prevent the user from seeing something like, the divisor of the operand had a, flux capacitor state of, no one can read this stuff, right? So in that case, you can kind of shelter them from the scary messages and just say something went wrong. But if you know that the message you're catching is user-friendly, like it's from us, then we can actually print that message to the screen. Also note that param name was one of the options I could pull out. So in this case, now when I run it, it says we cannot divide by 0. The parameter name was v. So it allows us to see very easily that user-friendly message and even what the name of the parameter was, if we want to go that far. Okay, so now we can kind of improve our application and make it work a little better. Now, let's address the int problem. We talked to our boss, and our boss says, yep, that was a mistake. It should have been double because we have division in there, and we don't want that weird rounding to happen. So let's do a Control H. Control H brings up the replace dialog. So Control F brings up find. And you can choose the current document, all open documents, entire solution, whatever you want. But Control H, a similar option here, where you want to do a search, and then allows us to say search for this and replace with this. In this case, I've already got preloaded. Search for int and replace it with double. I'm going to do this just in the current document. Now I could do just replace one. That's this icon right here. And it's going to do one at a time. And I can just keep hitting it. And it will show me what's going to replace. Or I can say, you know what? I know it's for a fact this is fine. I can do replace all. That one's scary. Okay? So be careful of that one. But you can use it. In fact, I'm going to use it. I'm going to hit replace all. And it says 16 occurrences replaced. Now, the very first thing I do, I'm going to say build solution just to make sure it builds. And it does. There's a build solution or build succeeded message down there. But the reason why is because that immediately would tell me if something really bad went wrong. Now, I knew there were no comments that had int in them or, words that had like interior starts with int. Now it's double terior. So that's one of the things you have to look out for. But in this case, I knew that I was safe doing it. Now, if we run this application, we can't divide by 0 still. Okay, so let's change that to be 2. 4.86 repeating. Let's change it to 3 and run it. 4.76 repeating. Okay, so we're seeing some value changes here that look better. 4.73 repeating. And so you can see that, if I change to 45, it processes and it looks like it's changing the value. So it looks like maybe our application is operating more as expected. Now, I don't know what all these formulas do and if they should be performing these actions the way they are. But the basic checks that I've done so far with my different types of breakpoints and making sure I wrap things in if statements and throwing new exceptions if I need to, all that stuff kind of improved my application in areas that I knew were problems. And now I can address the rest and say, well, is this really the valid formula that we were expecting? Okay, so even though I know nothing about this application, even though I don't know how it works or why it works, I can use my breakpoints to understand better the flow. So I can get this list here of the order things are called in and what the inputs and outputs are, and maybe even some internal values if I wanted to. And I can kind of walk through the process of understanding bits and pieces at a time. It's really investigative work. You are a detective on the case of the bug, and you're trying to find the bug, and you may find other bugs along the way. Or you may find that the bug that you thought was the bug was really a feature. Or maybe it was one of many. Or maybe it was, one that actually caused other bugs when it got fixed. So the key here is patience. And that actually brings us right into our tip, which is that patience and persistence are your friends. The key with debugging, the key with trying to find where the errors are and trying to make your application work the way you expect it to. The key is to be patient, to not get discouraged the first time you have a setback, or not get discouraged the first time that you bump your head against a wall, or the 5th time, or the 10th time. It really is a process of making small little steps towards the end goal. Just keep pulling at it. Step through different pieces. Use different breakpoints to kind of hone in on the problem. Look at things and see where they don't make sense. Just debug one method at a time, or look at that flow of the application and take it step by step. Whatever it is, be patient in case that the fix that you thought worked doesn't work, but also be persistent. Just keep at it. Okay? If you do those things, you will conquer debugging. I have had a number of problems where I thought for sure there was no solution, or I thought for sure that it was actually Microsoft's problem. I don't know how many times I have blamed Microsoft. It's their stupid application. It's not working the way they say it is. And, for whatever reason, they wrote .NET wrong. And there's a bug in .NET. And do you know what happens 99.99% of the time? I find out it's my problem. Okay? Because I wasn't being patient. I thought that I had just assumed that my code was right. And guess what? My code was not right. Okay? If you have to assume that you made a mistake. Just be patient about it. Don't worry. It's not the end of the world. Just keep plugging away. And remember that the more you do this, the better you will get at it. That does not mean that you will just have this laser-like focus of, boom, there's a bug. Boom, there's the bug. That's not going to happen. Not at least for most bugs. Okay, for the easy ones, sure. You'll get better at that. But what you'll be able to do is more easily track them down, more easily know what tools to use when. So just be patient, be persistent. I know I've repeated that over and over again, but there's a reason for it. And that is you need to learn it. Okay? So your homework. This is a little different. Normally I'd say practice, but again, it's hard to practice these things. Now you can download the source code, and I encourage you to, and try what I did, and maybe find more bugs. There might be a few more hidden in there you might want to find. In fact, I know there is. But keep an eye out for bugs in your future applications. When they come up, use the skills you've learned in this lesson instead of avoiding the issue. So if you're following along with what I'm doing on the screen and yours doesn't work the way that mine does, your first reaction shouldn't be email Tim. Okay? Now, I don't mind emails. I love emails. And I try to respond to as many as possible. But that shouldn't be your first response. Your first response should be, this is an opportunity. Let me track it down. Let me try out my breakpoints. Let me try to figure out how to do this. Okay? Take the opportunity and find the bug. Okay? Work at it. Spend time on it. One of the things that might help is to walk away. Then come back. Okay? One of the things I found over the years is if I can get a shower. Because in a shower, I tend to let my mind drift, and it will kind of in the background work on the problem while I'm thinking about nothing or something else. I get out of the shower, I come back, I fix the problem. Or I know where to find the problem, or I know how to find it better because my brain has kind of worked on it. And that's an experience thing, but it's also just a refresh your brain or reset. Okay? So try that out, but definitely see bugs as an opportunity, not as something to be avoided. All right. Thanks for watching. Up next is your quiz. Hopefully you get 100 on it, and then you can move on to the next course.